So today we'll be looking at capital budgeting in a very concise manner. So what is capital budgeting? It is actually investment in long-term assets, which requires long-term decision making, whether to invest in an asset or whether to invest in a project or not. There are a few steps in capital budgeting problems. The first step is calculating the weighted average cost of capital. The next step is calculating the net present value and or the internal rate of return, the IRR. And finally, we make a decision whether or not to invest in a project. Starting with the net present value, what is net present value? It is the sum of present values of all cash inflows and cash outflows of a project. And if how do we interpret NPV? It is how much value a project adds to shareholder wealth. So the higher the NPV, the higher the value added. And therefore, we are more likely to choose the project with the higher NPV. And it is cash flow invested at WACC, that is the weighted average cost of capital. The formula for NPV is as follows. We sum all the cash flows, divide them by 1 plus R, which is the WACC, whole to the power T. That is the look at an example of net present value. In this question, WACC is 10%, and and the cash flow of project A is given as follows. So for year one, we have negative 100, which is an outflow. Then for year 1, 2, and 3, we have positive cash flow, which means we have cash inflows. To calculate the present value of the cash flows, we'll use the present value formula. So we'll divide negative 100 by 1 plus 0.1, which is the weighted average cost of capital, times whole to the power 0, which is year 0. For year 1, we have cash inflow. We'll divide 10 by 1 plus 0.1 whole to the power 1. And the present value of cash flow at year 1 turns out to be 9.09. We'll do the same for year 2 and same for year 3. Then we'll sum these present values. So we'll add negative 100 to 9.09, then we'll add which we'll add to 49.59, then we'll add it to 60.11. So the net present value turns out to be $18.79. Now, this is what we do using the formula. Now, if we were to use a financial calculator, this is what we'll do. We'll plug in the cash flow at year 0 as negative 100, cash flow at year 1 as 10, cash flow at year 2 as 60, and cash flow at year 3 as 80. We'll plug in the interest rate as 10% and calculate the net present value, which will turn out to be $18.79, same as we did using the formula. Now let's look at the cash flows of project B. So for year 0, the cash outflow is negative 100. We'll use the same formula that we used earlier to calculate the present value of these cash flows. And the net, when we'll add these present values, the net present value will turn out to be $19.98. Now let's look at how we'll use the NPV for decision making. So before that, we need to know that there are two types of projects. There are independent projects, and then there are mutually exclusive projects. In independent projects, the cash flows of one project are not dependent on cash flows of the other project. But in mutually exclusive projects, cash flows of one project are dependent on cash flows of the other project. So when we are using the net present value for decision making, in case of independent projects, we will accept the project if the NPV is greater than 0. And in case of mutually exclusive projects, we will select the project which has the higher NPV of the two. So in the previous example, the NPVs were as follows. The net present value for project A was $18.79, and the net present value for project B was $19.98. So if projects A and B were independent, we will accept both the projects since the NPVs of both the projects are greater than 0. But if they were mutually exclusive, we will choose a project which has the higher NPV, which is project B. So the next indicator that we use for decision making is the internal rate of return. It is present values of cash inflows equal to present values of cash outflows. So we plug in NPV as 0. And the internal rate of return is cash flows invested at IRR. The NPV was cash flows invested at WACC, and this is IRR. How do we calculate IRR using a financial calculator? What we do is we enter all the cash flows first, and then we press IRR. And generally, IRR equals to the yield to maturity of bonds. In questions where IRR is already given, we assume that it is equals to YTM. Now let's look at decision making using IRR. So if the projects are independent, we will accept both the projects if the IRR is greater than the weighted average cost of capital. But if the projects are mutually exclusive, we will accept the project if with the higher IRR. Now, when we're using IRR as our indicator for decision making, we encounter a problem which is called the multiple IRR problem. So what happens is that sometimes the financial gives error when we are calculating IRR, which means that there is more than one value of IRR and we don't know which one to use. So to remedy this, we calculate the MIRR, which is the modified internal rate of return. Now let's look at the modified internal rate of return. MIRR is cash flows that are invested at the weighted average cost of capital. There are three steps to calculate the MIRR. The first is that we calculate future values of cash inflows at the weighted average cost of capital, which we also call the terminal value. Then we find the present value of cash outflows. We plug in these values in the MIRR formula and find the MIRR. Let's look at an example. These are the cash flows for project A. So for year one, we have cash outflow of -100. For year one, we have cash inflow of 10. For year two, we have cash inflow of 60. For year three, we have cash inflow of 80. Now, to find the present value of all the cash inflows, there are three cash inflows. That is 10, 60, and 80. We'll use the future value formula. So for year three, the future value will be 80. For year two, the future value will be 66 at 10% WACC. For year one, the future value will be 12.1. We'll add all these future values of the cash inflows and we'll get the terminal value as 158.1. So we'll add 80, 60, and 12.1 and we'll get 158.1. Now the present value of cash outflow is -100. The MIRR formula is that we put NPV as 0 and use the terminal value and divide it by 1 plus MIRR whole to the power 3. That is because there are 3 years. And after plugging these values in the formula, we'll get MIRR as 16.5%. Now, if we use MIRR as our decision making, if the projects are independent, we will accept both the projects if MIRR is greater than the weighted average cost of capital. If the projects are mutually exclusive, we will accept the project with a higher MIRR. Now let's look at the decision making using all these three indicators, that is NPV, IRR, and MIRR. For independent projects, NPV, IRR, and MIRR reach the same except reject conclusion. But for mutually exclusive projects, they might give conflicting conclusions, which means that the NPV might be telling you to invest in project A, whereas the IRR might be telling you to invest in project B, and the MIRR might be telling you to invest in project A. So these are the conflicting conclusions that these indicators might give you. Therefore, for mutually exclusive projects, NPV is the most reliable decision-making criteria. And in general, NPV is superior to IRR and MIRR, whereas MIRR is superior to IRR. Let's look at the graphical representation of conflicts in mutually exclusive projects. So this is what happens when there's a conflict for two projects that are mutually exclusive. This is the NPV profile for project A, and this is the NPV profile for project B. Now, if the weighted average cost of capital is less than the crossover rate is where the NPV of project A intersects NPV of project B. Now, a conflict occurs when weighted average cost of capital is less than the crossover rate, which is this area. And there is a conflict as the net present value of project A is greater than net present value of project B. And so according to this, you should invest in project A. But when we apply the IRR criteria here, the IRR of project B exceeds IRR of project A. So the conclusion is invest in project B. So these are two conflicting results that you reach. But if the weighted average cost of capital is greater than the crossover rate, which is this area, there will be no conflict, as the net present value of project A will be greater than present value of project B. So the decision will be to invest in project A, and the IRR will give the same conclusion, which is IRR of A will be greater than IRR of project B. So the decision will be to invest in project A. Now, in a few questions, the examiner asks you to calculate the crossover rate. So you should know this. To calculate the crossover rate, what you do is you find the cash flow differences of the two projects. So this is the cash flows for project A. This is the cash flow for of project B. What you do is you find the difference in them. So you subtract -100 from -100 for year zero. So for year zero, the change in cash flows is zero. For year one, you subtract 10 minus 70, and the change in cash flows is -60. For year two, uh, we do 60 minus 50, and the change in cash flow is 10. Same for year three, we subtract 20 from 80, and we get positive 60. We enter these cash flows in the financial calculator and press IRR to find the crossover rate. Now, the last concept in the capital budgeting topic is payback period, which is the number of years required to recover a project's cost. So what you do is you add cash inflows to the cash outflow until the cumulative cash flow stream becomes positive. Now let's look at an example for payback period. These are the cash flows for project A. That is, we have -100 for year 0, 10, +10 for year 1, +60 for year 2, and +80 for year 3. What we do is we add the cash inflows to the negative cash flow, which is the cash outflow. So we add 10 to -100, and we get -90. Then we add +60 to -90, we get -30. Then we add +80 to -30, we get +50. So the payback period is 2 plus 30 over 80. Then what we do is we divide 30, that is the amount that is still to be recovered, by the positive cash flow of year 3, that is 80. And the payback period turns out to be 2.375 years. Now, there's another method to calculate the payback period, which is the discounted payback period. And we use this method because the simple payback period ignores cash flow streams after the payback period and doesn't consider the time value of money. So it isn't an accurate measure of the actual payback period. So to find the discounted payback period, this is what we do. We find the present values of the cash flows using the same present value formula. So the present value for the cash flows is -100, 9.09 for year 1, 49.59 for year 2, and 60.11 for year 3. Then we add these cash flows to find the cumulative cash flows. That is -100 plus 9.09. So we get -90.91. Then we add 49.51, and we get -41.32. Then we add 60.11, and we get 18.79. So the discounted payback period is the whole 2 years, because we aren't able to recover the entire sum in these 2 years. And then to find rest of the payback period, we divide the amount that is yet to be recovered, that is 41.32, by the positive cash flow of year 3, that is 60.11. And the discounted payback period turns out to be 2.7 years. This was the capital budgeting topic, and we'll be doing the exercises of this topic